Okay, class, in this lesson, you are going to learn to understand angles in standard position. And just as a side note, this is in preparation for learning and understanding trigonometry. Okay, so let's go ahead and get started. Okay, so in this example, we are to find the measure of an angle in standard position. Okay, so now before we start to solve for this problem, let's define some things and just kind of identify what's going on here. Okay, so first things first, here we have a side of an angle in blue, and then we have another side of an angle in green. Okay, now I have these labeled in different colors because they have different meanings. So this side here, which is on the x-axis, and that starts at the origin, okay, that side of the angle is called the initial side. And then the other side of the angle, which I have in green, this is called the terminal side, okay? Now, this terminal side could be in any position, okay? It could be over here, it could be over here, where it is notated here. It could rotate around a full 360 and continuing on. But no matter where it is, the pivot point is always the origin, okay? And terminal side tells you that where the angle actually ends. Now, here we also have the angle theta, okay, representing that angle. And the angle represented by theta, that is considered in standard position, okay? Standard position where the initial side begins on the x-axis, and then we have the terminal side. Okay, so now that we've defined all of this, let's go back to the question at hand, and that is, what is the measure of this particular angle in standard position? Okay, now the only piece of information that we're told is this coordinate here. This is -4, 4 square root of 3. Okay, so how do we do this? Just at a very high level, what we want to know is to figure out this angle right here from the terminal side to the x-axis. Okay, if we can figure out this angle, then we could take the full angle of this axis, which is 180, subtract this angle, and what's left would be the angle theta. All right, so let's see, how would we do this? Well, from the point, the coordinate that's given to us, we can drop a dotted line and create a right angle, okay? And what we noticed here, based on these coordinates here, -4 tells me that the distance from the origin to this point here is -4. So that is really a distance of 4, okay? So we'll call this 4. And then the distance from the x-axis all the way to that coordinate, or the actual y coordinate, that distance is 4 square root of 3, okay? All right, so if you notice, because this is 4 and this is 4 square root of 3, okay, this really represents a 30, 60, 90 triangle, okay? If you recall, in a 30, 60, 90 degree triangle, I'm going to draw here in blue, okay, assuming that this is 30 degrees and this is 60 degrees, okay? Whatever this value is, let's say this is x, this distance is x, based on the 30, 60, 90 triangle, we know that this is going to be x square root of 3, and then the hypotenuse is going to be 2x. Okay, if you could use the Pythagorean theorem and plug in some numbers, and you'll see that this will work out according to the pattern that I've noted here. Okay, all right. So because we know that this is a 30, 60, 90 degree triangle, okay, we know that because this side here is 4 square root of 3, then this angle has to be 60 degrees. All right, so let's go ahead and label that. That's going to be 60 degrees, which means our angle theta is going to equal 180 degrees, which is this angle of a straight line, okay? And we're going to subtract 60 degrees, which we just calculated over here, and that should give us theta, okay? And so theta, which is what we need to find, is 120 degrees, okay? And so there is our answer. Okay, let's move on to the next item. Here we're talking about coterminal angles, and the question is, what are coterminal angles? All right, so I'm going to go ahead and define it. Coterminal angles refers to two or more angles that share the same initial side and terminal side, okay? So I'm going to say two or more angles that share the same initial side and terminal side. Okay, so essentially they share the same initial side and terminal side. Okay, so what does that mean? Well, we could technically have an angle that starts at the initial position, okay, this initial side, and instead of rotating 120 degrees, okay, counterclockwise, we can actually rotate clockwise. Okay, so if we rotate clockwise, that gives us an angle of negative 240 degrees. Okay, now how did I arrive at negative 240 degrees? Well, we know that a full rotation, whether clockwise or counterclockwise, will reach 360. So if we go clockwise, we're going to go to negative 360. If we go counterclockwise, it'll be 360. And since we went clockwise, we didn't quite reach 360, but what I did was I took 360 and I subtracted 120, and that gave me negative 240. Okay? And then the other thing we could also do is move from the initial side and go counterclockwise, but instead of stopping here, we would continue with a full rotation, so that's 360, and then plus 120. Okay, so let's go ahead and draw that out. I'm going to do this in blue, so we're going to go a full 360, okay? But instead of stopping at 360, we're going to continue on to the terminal side, okay? And so that means that our angle is going to be 360 degrees plus 120 degrees, which gives me 480 degrees, okay? So if we're able to do this with one full rotation and then finish up at the terminal side, we could actually go 2 rotations and then finish at the terminal side, 3 rotations, finish at the terminal side, 4 rotations, finish at the terminal side, and I think you get the idea. We can go on and on and on and on, okay? So really what we have then is we're going to say 360 degrees k times k plus 120 degrees, where k represents number of rotations. Okay, so we could technically have an infinite number of coterminal angles. Okay, so hopefully I've helped you to understand what coterminal angles are and the potential possibilities. Okay, now obviously we went counterclockwise, but we can also go clockwise as well and find the same number of potential coterminal angles as well. Okay, so let's go ahead and move on to example 2. Okay, now we're talking about reference angles. So what are reference angles? I'm going to go ahead and define it and then explain it in just simple terms. Okay, so when an angle is in standard position, like this is in standard position where you have the initial side on the x-axis and then you have a terminal side. The reference angle is the acute angle formed between the terminal side, so that's this here, of the angle, and the x-axis, okay? So this angle right here. So basically, the reference angle is regardless of where the terminal side is, okay, whether it's here or here or here, the reference angle is going to be the angle closest that is formed between the terminal side and the x-axis, okay? But it will always be less than 90 degrees. The reference angle will always be less than 90 degrees. So for example, we have a terminal side here, okay? We want to figure out what this angle is. So if we know this is 130, then we know that this angle is going to be 180 degrees minus 130 degrees, which is going to be 50 degrees. Okay? Let's take a look at another example. Okay, here's a question. What is the reference angle for a 200-degree angle? Okay, so here we have an initial side over here, starting on the x-axis, and it rotates all the way over here, and this is 210 degrees. Okay, so then the reference angle that we would want to solve is right here. This is the angle between the terminal side and the x-axis. Okay, so this is going to be right in here. So then my reference angle is going to be 210 degrees minus 180 degrees, and that gives me 30 degrees. Okay? So what we did was we took this entire angle, okay, and we subtracted this angle here, and we're left with a balance of 30 degrees. Okay? So if you notice, in the previous example, we took 180 degrees and subtracted the given angle. Okay? Whereas in this case, we took the given angle and we subtracted 180 degrees. Okay, so now the question is, in the first example, we started with 180, and in this example, the second term was 180. How do you know which one is which? Okay, in reality, it doesn't matter which is which. You could go in any position. You can go in any direction. So, for example, you could technically go 130 degrees minus 180 degrees, but just remember, you're always going to take the absolute value. So this is going to give you 50 degrees, okay? And then in this case also, you could take 180 degrees and subtract 210 degrees, but remember to take the absolute value, and that's going to give you 30 degrees, okay? So your reference angle is always going to be between 0 and 90 degrees. Okay, let's move on to the last piece here, and that is now we're given a reference angle of 45 degrees, okay? So we've got the initial side, and it's going clockwise, and the terminal side ends at 45 degrees. And we know that a terminal side lies in quadrant 4, okay? So just as a review, in case you're not aware of this or you forgot what this was, quadrant 1 is in this region here of this X and Y axis. Quadrant 2 is over here. Quadrant 3 is in this section. Quadrant 4 is in this section, okay? So if you think about quadrant 1, this is the plus side, positive X, positive Y, okay? If you start over here and you go counterclockwise, you can go 1, 2, 3, 4. That's one way to remember it, and this is the way I remember the quadrants. So I always start with 1 here, and then I just go counterclockwise. And that tells me the remaining 3 quadrants, okay? So we're told that the reference angle in its terminal side ends or lies in quadrant 4. And the question here is, what are a positive measure and negative measure for this angle, okay? What is a positive measure and a negative measure for the angle? If you recall, if we go counterclockwise, we're going to be positive. If we go counterclockwise, we're going to be negative, okay? So let's just go ahead and write that down. Counterclockwise implies positive, and then clockwise implies negative. Okay, so we want a positive measure, so if we start at the initial side and we rotate all the way around a full 360 and we subtract 45, that's going to give us the same, or that's going to give us a positive angle, okay? So let's go ahead and do this in green for positive. So 360 degrees minus 45 degrees will give us a 315 degree positive measure. Okay, and then to go negative, we're going to go in this direction, right? Clockwise. And in this case, there's really no calculation here. Going clockwise will give us a negative 45 degree, and that would be our negative measure for the angle. Okay? All right. Hopefully this made sense to you. I know that this is, for some of you, this might be new, and for others, this might just be a review. But for those of you who, where this was new, I would recommend that you go back to the beginning of this recording and listen to this again, because there's a lot of information that you're taking in, and it would be good to just kind of go over it just to kind of reinforce what you learned. All right, thank you so much.